Now, hopefully, you've constructed this picture, which, except for the color, is identical to this picture, except for the fact that your doubling displacement is 1/2, which means if I want to draw the arrows, I've got 1/2 here, I've got 1/2 here, telling me that my x coordinates are -1/2 and 1/2. Again, I've got the 0.01 on the graph. That makes no difference. The doubling displacement makes no difference. Y equals b to the x always goes through the 0.01. So from this, I determine my slope here and my slope here. If you haven't already done so, do so now. Okay, now you should have done that. If you just really can't do that, you should understand that this point is -1/2, 1/2, and this point is 1/2, 2. And now you have the coordinates of this point and this point, so you can find the slope. You have the coordinates of this point and this point, so you can find the slope. You can find the rise, you can find the run, so you can find the slope. So you ought to do that now. Okay, you should have gone through the reasoning that the rise from here to here is from 1 to 2, which is a rise of 1, and the run is from 0 to 1/2, which is 1/2. So rise divided by run is 1 divided by 1/2, or 2. So now the slope here is 2, and similar reasoning over here. The rise is 1/2, the run is 1/2, the slope is 1. Now, I wrote out an inequality for the slope of the tangent line. You should pause and write out that inequality if you didn't already do it. So I'm going to go ahead and do it, but you should have done it now. So that 1 is less than the slope of this thing, which is the tangent line, which is less than 2. Okay, now we want to write out a statement comparing the value of the function to the slope. How does the value of the function at this point compare to the value of the slope? Well, I can say that now the value of the function is less than the value of the slope. Okay? If your doubling displacement is 1/2. Okay, so I'm going to conjecture that for some doubling displacement between 1/2 and 1, the value of the function is equal to the value of the slope. So, a really short piece of chalk here. That was just about as bad. Okay.
I'm here. All these buildings around here, but I'm doing the racing. What does racing do? Am I here taking racing?
For some doubling displacement,
Yeah, I'm a little bit different. If I quit, I'll play that white ball.
between 1/2 and 1,
I'm doing, and I guess what this thing, I got everyone, it's doing the racing. I don't understand.
the value equals the slope. And once we've established that, we can establish that the value is equal to the slope at every point. Okay? Now there's a little bit to that argument, but it's accessible to you. You'll understand it once we understand how we transform functions and shift them and stretch them and so forth. Something you should understand at this point, but it was fuzzy for me when I was at your point, so I expect that it's fuzzy for a lot of you. So, the conjecture, for some doubling displacement between 1/2 and 1, the value of the exponential function at the y-axis is equal to the slope at the y-axis. And that's our sweet spot. Things are getting awful cluttered here. That's the sweet spot that we're trying to find. So there are two sweet spots that we want to find.